So let's look again at the scoring index by Earnshaw Cook. The first scoring index he describes is in his 1964 book, Percentage Baseball. And this is the formula, and it looks very complex. What this represents is pretty straightforward, though. We can break this down and better understand it and then reconfigure it so it's even more understandable by today's sabermetricians. The P here, each of the P's in the formula represents probability. So the whole scoring index, and he calls this DX, his little abbreviation for scoring indexes. P stands for probability. So the probability that you score a run is given by the scoring index. And it involves a constant multiplied by a term which includes the probability of getting a hit, the probability of getting a walk, the probability of reaching on an error, probability of hit by pitch. You subtract out extra base hits and sacrifice hits, and then you multiply the whole thing by the probability of the total bases. So this is his first formula, and we can reconfigure the formula to look like this and convert it to something that looks a little bit more like runs rather than the strange probability equation above. So this probability equation is a little cumbersome, but you can think of it as occurring on every plate appearance. You can think of it as the entire equation has plate appearances in the denominator. That's what probability of an event happening implies. So this equation can be reconfigured with plate appearances in the denominator. And you get a new formula like this. DX, this scoring index formula by Cook, that implies something like runs, is a constant times this term here, which is singles, and singles comes from hits minus extra base hits. Hits is total hits. The extra base hits are the non-singles. So this is essentially the probability of a single, a walk, reach on air, and hit by pitch. So we reduce this term here by just making it singles. And we subtract twice the sacrifice hits. Now, sacrifice hits are not in favor by Cook at all, so he adds this in his formula. So this is the first term here, and he multiplies the whole thing by total bases. But the implication is that it's all divided by plate appearances. So we can convert Cook's probability form of his scoring index equation. The probability form is this one here. We can convert it by the implied division by plate appearances that's inherent in the probability of scoring runs by the team when that batter is at the plate. So we get this new form. And there's a lot of familiar things in here, but it's a little different. He's got total bases divided by plate appearances, which looks similar to slugging. He's got on-base sort of things divided by plate appearances, which looks similar to on-base percentage. It's not quite what we've seen before in terms of OPS, but it's OPS-like. It's similar to OPS in a way. So this is his 1964 formula. In 1972, Earnshaw Cook comes out with a second book called Percentage Baseball and the Computer, which is essentially a shorter book, but running all his ideas through a simulator, through a computer simulator. And he changes his scoring index formula. So this is the first version. Runs are essentially getting to first base, taking away double these sacrifice bunts, multiplying by total bases, and divided by plate appearances. Well, this is the second form of the scoring index by Cook. And this is explicit in his book. He changes the formula to be hits plus walks plus hits by pitch, multiplied by total bases, and he adds another term in here around stolen bases. He adds stolen bases and takes away caught stealing, and then divides by some form which is almost plate appearance. This is almost plate appearances. So it looks a little like OPS and runs created. They're More like runs created than OPS, because this is a multiplication term than an addition term. Some form of getting on base divided by similar approximation to plate appearances. It's multiplied by total bases. You take in the stolen base success to get sort of another measure of movement around the bases, again divided by some estimate of plate appearances. So this is his new scoring index. And so Cook describes both of these things. And these, again, are, in some way, they're an estimation of the impact of that batter on runs. The impact of the batter on runs. Now, he frames it in the beginning in a little more complicated terms, using percentages of runs scored when that batter comes to the plate. We've seen similar formulas to this before, but remember, this is published in 1964 and 1972. So he really is one of the pioneers in this whole area, looking at another measure of run scoring. Now, this is similar again to what Roth and Rickey did. Bottom line, these two formulas by Earnshaw Cook share similarities with OPS. OPS comes out in 1973, invented by Pete Palmer, and shares some similarities with runs created by Bill James even later than that. So the history of sabermetrics should recognize these contributions by Earnshaw Cook as part of the progression of measuring hitting performance. The other thing Cook offers is probability of run scoring in each of the 24 game states. The three potential out states are 0, 1, or 2 outs. And this is multiplied by 8 different base states, the runners on base. There can be no one on base. And I'm going to represent by 3 dashes. There could be a man on first. And there can be a man on second. And a man on third. There can be men on first and second. Men on first and third. Men on second and third, and then, of course, men on all bases. This describes each of the different states of having men on base. So we can think about the game, and people started doing this early on, that there are 24 states. There's an out, and then there's a runner on base state. This ends up being 24 cases. So what Cook does is describe the probability of scoring runs in all these different game states. So he devises 24 different equations for the 24 different game states. And he has this huge complex probability model for each of these game states. And he bases it on run scoring. This was done earlier in the 50s by Lindsay, who we'll cover next week. This idea of looking at run expectancy, run probability. But Cook does it early as well, too, and he does it with this complex probability model that he used also for his scoring index. But the reason he thinks he's onto something here, Cook likes his idea, is he actually gets to percentage baseball. He can look at percentage baseball because he can see, based on the scoring index of the batter, the batting ability of the batter, the probability that batter will lead to a run by the offense, also spinning in each of the probabilities that can occur with each of the 24 game states. He can start describing how the game will play out, that you can really play percentage baseball at this point. You really can play percentage baseball at this point because you know the percentages. You know the percentages of all the different game states, the 24 game states, and you know the percentages of the scoring index based on the batter who's at the plate.